Good afternoon and welcome to our EU Knowledge Valorization talk today. I'm Stefan Dong and I'm responsible for the valorization of EU research results in the Directorate General for Research and Innovation here in the Commission. I will be your moderator today and I'm very pleased to have all of you online today with us for that talk. Today we will explore some of the ways to tap into the market potential of the scientific findings that we are producing in Europe. We know that we have great results, but we need to do more to make them and to create value for society and for economy. In the Commission, we provide a range of support services to the Horizon project beneficiaries to help them turn their results into real-world application and to create value. We also put in place policy, such as the recently launched EU Startup and Scale-up strategy that include measures to accelerate the commercialization of the results. Also, the European Research Area Policy Agenda for 25 to 27 continues to put the focus on knowledge valorization with a set of dedicated actions. At the same time, of course, there is a lot happening in the different organizations throughout Europe to facilitate the uptake of scientific results. There are many innovative approaches within projects, in universities, in research organizations, and the experts that we will have today with us will introduce three of them. So let me introduce our panel today. We are receiving Matthew Edward, Joe Fornell, and Francesca Politi. Welcome, and thanks a lot for joining us. Before giving the floor to our speakers, I would like to invite you, dear audience, to already go to Slido with the hashtag EU Valorization Talks and send your questions for the upcoming Q&A session that we will have at the end of this session. Thanks a lot for your active participation. Let me now start the discussion and introduce our first panelist. Matthew, you are a commercialization officer at the European Space Agency, and in this role, you oversee technology brokers. Can you please tell us more about this initiative? How does it work in practice? How do you do tech transfer between the space technology and the various industries in your domain?
Okay, brilliant. Thank you, Stefan. I mean, it's a pleasure to be here. This year is actually marking 35 years since we established our technology transfer program. And actually one of the first initiatives that we first put together within this was actually our ESA technology brokers. Next slide, please. So our goal was to generate spin-off technology transfer cases. So that's identifying technologies that were originally developed for space and then applying them to terrestrial industries. Naturally, though, this doesn't happen by accident. It's highly unlikely that, let's say, an R&D manager in the automotive industry suddenly realizes that space could provide them with the solution to a materials science problem that they're potentially facing. That just doesn't happen. So rather than waiting for them to try and come to us, we have to make sure that we go to them, and that's where our brokers come in. So each one has a deep knowledge of the space industry within their respective countries, as well as strong ties to their different national industry bases. They actively engage with non-space sectors, learning what technical challenges are being faced, and then scouting for opportunities where space technology might provide a unique advantage in these. Space technology itself, it's quite a broad term, but there's some typical qualities that make it extremely valuable, actually, for a lot of high-performance applications. So the first being extreme durability. Obviously, space is a very harsh environment. So all the technologies, they have to take into account radiation, vacuum, extreme temperature changes. Not to mention also the vibration and G-forces during launch. Secondly, technologies have to be miniaturized and lightweight. So those two factors are key drivers of the cost when it comes to launch. So anywhere we can reduce those, absolutely critical. And the third one is about reliability. It's quite difficult to send an engineer up into space to fix something. So basically, systems are built to last, and often with various different redundancy parts built in. Our brokers work through a mix of technology push and market pull. And they act as matchmakers, basically, between problems and solutions. And they work as a network between all the different countries mentioned here. So actually, they're able to source technologies from all of these countries, not just their own. Then once a match is found, they then act more like facilitators, helping the projects move forward. One way in that the way that we help these early stage projects is through the brokers offering what we call a spark funding. So this is a quick access, low bureaucracy funding program, typically offering between 60 and 300,000 euros per project. And basically between a company applying and the project kicking off can be as short as 4 to 6 weeks. So it's a really quick turnaround, and industry very much values this. Next slide, please. Just a very quick example of one of our recent technology transfers. So this was done by a German company called TerraPlasma. On the right-hand side, you can see one of their an experiment that was flown on board the International Space Station. And this was looking quite into the, let's say, fundamentals of plasma physics, which is, I think we can agree, probably as far away from a commercial product as you can possibly get. And with long-term support from ESA and the German technology broker, they've brought a variety of different products to the market that are based around this core technology. This latest one, called FLAS, it's a skincare point-of-care customer product. And it uses that cold plasma to treat conditions such as acne or other skin irritation problems, reducing the reliance that they have then on chemical creams or specific medications. So it's actually really gone from pure research through to a real consumer product. And I think that's just a really interesting example of how space technology is actually impacting people right on Earth today.
Yeah, thanks a lot. That's very interesting. I guess managing properly intellectual property is key in that context. Huh? How do you go for that?
Absolutely. So, I mean, ESA's sort of industrial and IP policy are quite intertwined. They've got a very clear aim, and that's strengthen Europeans' industrial competitiveness in space. And that includes on the global stage. So most of ESA's R&D is actually carried out in collaboration with or directly by industry. So to encourage those companies to protect and then further commercialize their innovations, ESA's, let's say, default setting for IP is that the contractor actually retains ownership of that IP, while ESA receives then a license for that we can then use it for our own mission-related purposes. I mean, this comes really as a win-win. The companies are able to then develop competitive IP-rich products, and ESA gets to use those in its scientific missions and in exploration programs as well. Furthermore, it actually lays the groundwork quite nicely for the technology transfer and commercialization, since the IP is already in industrial hands. And then our brokers can then work with these companies to support in finding them spin-off opportunities.
Thanks a lot, Matthew. Very interesting. Let's move now to our second speaker, Joe. You're an innovation advisor at Linköping University in Sweden. Joe, what do you want to achieve with the Summer Match Entrepreneurship Program? What are the outcomes so far, maybe? Could you give us examples?
Thank you very much, Stefan. Next. So, Summer Match, it's a little bit of a equipping, but much that is, we are matching the needs of researchers and of students, and all in the context of knowledge valorization. And if we start with the researchers, they typically have good ideas for valorization, or at least with potential for valorization. But they need to have help with market verification. That's very common. In some cases, they need to do things like customer surveys, etc. And sometimes they have research fundings, but they are looking for specific application. And sometimes also they want to have help with making prototypes or dummies. the students, there are a number of students who want to work with innovation, but they have sort of no idea on their own to work with, but they want to work in that context. And they also want to have experience, not only a degree, but they are starting to build their CV and the portfolio and things like that. And the third, most students also want to have a paid summer job. And we match those needs. And next, please. In a nutshell, we ask the students to work for 5 weeks during the summer vacation with specified tasks from the researcher. Very common is market verification. And what I get is that we work together with a business incubator lead, and they provide professional innovation coaches. So they are coached all through the process. And often we try to work with 2 students at the same project. And they should in some way have perpendicular competences. So you could have 1 engineering student and 1 business student, or 1 business student and 1 social science, etc. That gives some dynamics. And we have some funding from the Swedish innovation agency Vinnova. And the results so far is that during, I think we're running it for the 14th time this summer, we have worked with 200 projects. That has resulted in 32 patent applications. And 69 projects have received some external mainly soft funding to take the projects further. And all in all, we have contributed to making 83 new companies. And just to say a little bit on the demand from the student side, every year we have 20 positions where they work at this business incubator lead, and we have 200 applicants for every year. So we have a lot of good students to choose between. Next, please. So I'm working with Linköping University. We are closely associated with the business incubator lead, which are doing the actual execution. All the researchers' ideas and the students, they come from Linköping University, but it's the incubator who's doing the actual work. And Linköping University is working in the context of European Alliance, ECIU. And more specifically, we are within this alliance, and we are pursuing a project called SetNova, where we are building capacity for knowledge valorization. And please feel free to contact me if you want to know more about it. So that's what we do in a nutshell.
Many thanks, and very interesting experience. I mean, do you consider this is something you could scale, or is it easy to replicate in a way? Maybe also what has been the impact on your own university?
Yeah, I would say that yes, it is scalable, and we have had questions from other Swedish universities to sort of transfer this. It has not put into a sort of specified format which you can use in a license, but yes, it is scalable. I think there's nothing unique with Linköping University. I think the needs are there in many places. Yeah.
Thank you very much.
Thank you.
Let's turn to our third speaker, Francesca. You're project manager in the Agency for the Promotion of European Research in Italy. And you're here to present the EU-funded project called Forging. The objective of your project, if we understand correctly, has been to develop use cases for emerging technologies, taking into account their environmental and societal impact. Can you tell us more about it?
Absolutely. First of all, thank you very much, Stefan, for the introduction and for the invitation to this great panel. Indeed, the development of concrete use cases for emerging technologies of Industry 5.0 was one of the very core outputs of the Forging project. Forging is a coordination and support action funded under the Framework Program of the European Commission, and it ultimately aims at exploring how these technologies can be really leveraged in a way that help us to build a more sustainable and a more human-centric future of industrial innovation. To co-develop these use cases, we at APRE held 6 in-person workshops across the European Union, 1 per each technological framework of Industry 5.0, as you can see in the slide. And to these workshops, we saw the participation of more than 130 European experts from across industry and research and academia, who co-developed 20 use cases covering among 10 plus than 10 sectors of application and adoption, say manufacturing, agri-food, public administration, and urban mobility, just to name a few. But what really matters here, I guess, is how we got there, how we achieved such results. So if we move to the next slides, I will show you. First of all, we reflected on technologies that are at very earliest stages of development processes, so technologies with very low TRLs. And what really made the difference is that we shift the focus of our participants towards one main question. How can technology be shaped around real societal and human needs from the very beginning of the design process? So rather than asking what do we do with this technology, we asked what can the technology do for us as human beings, as mankind? To answer this question, we developed a 3-steps methodology that was implemented through 3 different canvases. So in the first canvas, participants had to go through a first identification of a sector-specific need. So they identified an issue affecting their sector of interest, and they turned this issue into a concrete need. And then they started to envisage possible solutions that would be worth pursuing to address that need. And then they picked one of these solutions to move forward with. In the second Canva, they then further defined the key features of this solution, which would then eventually become their final use case. And they started detailing key resources that would be needed to develop that solution, key stakeholders to involve, but most of all, they identified one technology from the Forging portfolio of technologies that could best best help develop that solution. Then in the final step of the methodology, participants were asked to move a little bit backwards and to assess the risks, social and environmental risks connected to the solution that they had envisaged. So with the help of some specific tools like our perspective cards that were also developed by the Forging Consortium, they were able to really bring into the table various stakeholders' perspectives and different viewpoints when designing their use case. And in this way, they could really help themselves reflect on possible unintended impacts of their developed use case. So as you can see in this methodology, there's a great focus on human well-being in technological advancement, fully in line with what is the broader vision of Industry 5.0. So this is part of what we call the Forging Value-Sensitive Innovation Journey. Next slide, please. So in case you're wondering what our use cases look like, I will give you 3 examples, but then if anybody wants to have a closer look at all of them, you can just scan the QR code in the slide. So we had, for instance, one group that proposed a data-driven resilient farming system leveraging abductive reasoning AI to enhance efficiency and resiliency in the agri-food sector. Then there was another group that combined natural language processing and Internet of Things to improve communication capabilities and situational awareness in high-stakes environments like an aircraft, let's say, or a hospital. And then finally, one last example, one group designed a use case for cognitive digital twins to improve workplace safety in complex industrial environments through real-time monitoring and predictive risk analysis. Again, more details are in the QR code in the dedicated webpage.
Yeah, very inspiring, Francesca. What are the main lessons learned and what's coming next?
Well, I guess there are 2 key lessons learned here. The first one is that there is a much greater potential of generating positive impact when technologies are still being imagined. So at very low stages of design processes, at very low TRLs, rather than going backwards and reflecting on social and environmental values when a technology is already on the market. And second, that both industry and academia can really benefit from structured tools to co-create, for instance, our methodology or our specific tools like perspective cards, but they can also benefit from cross-sectoral kind of dialogue and interdisciplinary open discussions to really bring in as many perspectives as possible when designing a technology and when adopting a technology. As for what's next, this methodology and these use cases and all the lessons that we have learned throughout project implementation are going to feed into our forging toolbox and playbook. That is a useful resource that will be available at the end of September 2025, when our project will end. And it will be a resource for anybody working with novel enabling technologies that will help them navigate this complex landscape, this very layered landscape that requires the integration of many different perspectives in it. And on top of the toolbox, our consortium in these weeks and in the coming weeks is also supporting each group that co-created each use cases to further advance the use cases towards the market by designing together new research and innovation actions and innovation actions.
Yeah, many thanks. Thanks a lot to the three of you. We will soon be moving to our interactive session, replying to your question. But maybe before, a few questions, so don't hesitate. And you see maybe on the screen the Slido that you can use to continue to ask your question. Maybe before getting into this session, a few additional questions for you, Matthew. Can you maybe give us more insight on how you cooperate with industry and particularly with smaller companies across Europe?
Of course, absolutely. As I mentioned before, most of ESA's activities are done in some form of collaboration with industry. And as such, we do have a clear industrial policy aimed at building up the European space ecosystem. And naturally, a big part of this is supporting SMEs and startups. We have a dedicated SME office within the agency who plays a crucial role here. They help smaller companies to navigate the sometimes complex ESA procurement processes. They can ensure that fair access is given to ESA tenders. They provide training and guidance on how to do business in the space industry as a whole and also with ESA specifically. And they can also then help SMEs get involved in ESA missions and programs also. They hold a flagship event every other year called the Industry Space Days, based at our technical headquarters in the Netherlands called ESTEC. And it's a fantastic event for those looking to enter or grow their business within the space industry. When it comes to startups and entrepreneurs, we also offer a network of business incubation centers, ESA BICs. These are now in more than 70 locations across 23 countries. We're adding more all of the time, so it's always very difficult to keep up to date with these statistics. But these centers provide a combination of technical and business support for early stage companies, as well as some funding, both from ESA and a local co-funder. And what we're really looking to do is help get those early stage innovative companies off the ground, and that's whether they're applying space technology back on Earth or whether they're wanting to create new solutions also for the space industry.
Matthew. Joe, what more could be done within the universities to enhance the entrepreneurial spirit and skills of the researchers and students throughout all the disciplines?
I think there are two areas where I can do. First of all, within the education as such, I think, of course, we have specific entrepreneurship programs at many universities, but it's also important to have training or teaching in these subjects in all types of projects, so that you have, even if you're a specialist in something else, you have some training and preferably hands-on. And within our European Alliance, ECIU, we are working very much with challenge-based learning, where the students work with specific concrete projects. That's one way to enhance what you call 20th century skills. So that's within the education system. I think also in the ecosystem, you need to provide some support for students who wants to work with our own ideas. And I think you could call this incubation or pre-incubation or anything, but what they need is they need some sort of coaching from innovation advisors or other business coaches. But what is also very important is that you should enable communities where students with entrepreneurial ambition can meet and exchange ideas. In some cases, there will also be needed some financing, but I think the coaching, training, and community, that's important.
Thanks a lot, Joe. Francesca, how did you bring together industry and academia during your project?
Thanks very much for this question. I think it's extremely relevant in this context, and I think it also answers one of the questions that we just got. Actually, one of the core goals of the Forging project, beyond the co-development of use cases, was exactly that of bridging the traditional gap between research results and industrial innovation, especially at low TRLs, especially at the earliest stages of technology design processes, when usually communication and collaboration between developers, adopters, and end user is still rare and uncommon. So to address this challenge, what we did was to build a forum of experts, a community of European experts from industry, academia, even from policy making, because we got even institutional stakeholders engaged with our project, in the same room from day one, to really shape together emerging technologies that could help shape responsible and digital green transition. So what made it work? How did we get industry and academia work together at these stages of technology development? Basically, everybody had something to gain, and I will give you 3 examples. Let's say if you are a researcher, you could gain cross-sectoral dialogue, cross-pollination of ideas, and you got to feed strategic recommendations at the decision-making level, both in the European Union and at the national level. If you are a startup or an industrial stakeholder, you actually have access to not only specific tools and practices and like-minded professionals, but also to a broader vision that goes beyond the mere technical efficiency of a technology, and that gives you the big picture of social desirability or an ethical stress compass about the technology that is being developed and that you maybe want to invest in. And finally, if you are an investor, again, you would benefit from knowing which kind of technologies can be labeled as most promising from a social and environmental perspective based on, again, this preliminary ethical stress test. So in our case, this seemed to be working. We engaged more than 320 stakeholders physically and online across 32 co-creation sessions from the beginning of the project to now. And we are planning to do more by the end of the project. So it was really a matter of not really developing a technology and then wondering if it fits the society once it is on the market, but to bring everybody, society, academia, researchers, and industrials in the same room to give together the shape, the trajectory that they wanted to give to a specific technology.
Yeah, thanks a lot. That's very interesting to bring all these actors together. That's what many of us are trying to do, but that's not always so easy. So very interesting perspective. Many thanks to the 3 of you for your insights. I think the time has come now to take the questions from the audience. You can still come in using Slido. EU Valorization Talk, one more time. Don't hesitate to come in and to bring in questions. Let me maybe start with a question to you, Francesca. How do you get industry interested to participate into these initiatives?
Yeah, well, we gave many incentives to industrial stakeholders to come and engage with us. First of all, during our co-creation sessions, we gave them the floor, basically. We gave them the possibility to share with the rest of the audience, the rest of the participants, their own use cases, their own technologies, and the technologies that they have already adopted and how they can work. And also we provided them with what we think are useful tools for them to navigate this landscape, such as our 3 Canvas exercises, the perspective cards, and many other activities, like, for example, foresight workshops, in which we got them reflecting on potential scenarios of unintended and unforeseen impacts of new technologies. And it turns out that they were really interested in doing that, to really analyze the full picture of technology development, and again, not just the technical one. Also, industry was also really interested about hearing the academic perspectives and the societal perspectives. So industrial stakeholders were really interested in knowing, like, the opinion of civil society representatives that were also in the room, institutional stakeholders as well, and researchers themselves.
Thanks a lot. We have a question for you, Joe. When you involve students in commercialization of a researcher's invention, do you have to deal with IP rights, and how do you do that?
Yeah, we have to do that, and many of the projects are based on inventions that can be the subject for patents. In Sweden, we have this. We are one of the few countries in the world who keep the professor's privilege. So if a professor makes an invention or a patentable invention, he has the ownership of that, not only the intellectual but also the right to commercialize uses. So it's a little bit special, but they keep that right all through the process. The students are employed during the project, and they signed a normal employment contract, including a confidentiality agreement. So it's the professor or the researcher is in full control of his IP.
Thank you. And I see that the people online also have a question for you, Matthew. At the European Space Agency, how do you look for terrestrial technologies and try to find application in space? Do you have examples?
Of course. So actually, a lot of the pretty much all of the technologies that we use in space have terrestrial origins. What we then do at ESA and with industry is to adapt these technologies such that they can meet the rigors and demands of the space environment. After which we then also look at the spin-off cases. So quite often it's a spin-in, do some development, and spin-off. But in specifically how we look for new technologies, so ESA has a whole technology roadmap in terms of what technologies are needed to be able to meet our particular objectives, missions, etc. And then within each of these, they're subdivided into what are called harmonization dossiers, and these are by specific technology groups. And these are very forward-looking, ongoing. These are the kinds of technologies and capabilities we need to be able to achieve in order to fulfill our missions. So these are also open to industry to participate in, to provide their inputs, and of course, terrestrial technology providers, of course, very welcome in this. Our brokers also play a key role in this, because obviously they know what the key technological strengths are within their particular countries, and what they can do is bring those technologies to the right people in ESA. Some examples maybe, it's especially around materials, advanced manufacturing. The space industry is not always a leader in all these areas. We're very aware that, for instance, in automotive, that the processes and techniques, for instance, that they've developed there could be equally applicable to the space environment. So actually educating those kinds of companies that actually there is a business opportunity for them in space, and it's not just an R&D activity, there's a real commercial business opportunity for them. And making that connection via our brokers is one real concrete way of making that happen.
Thanks a lot, Matthew. I see we can take another question for you, Joe. Maybe a tricky one. Huh? Can these entrepreneurship programs be also used to valorize research in the field of social sciences and humanities? Do you have example?
Yeah, they can. And when it comes to social sciences and behavior sciences and education science, we do have examples. Still, there are many more examples from technology and the life sciences. But in terms of social science, we have humanities. There are no problem in principle, but we have not done it yet. And I think the valorization is a broad concept. I think you have the same issues in the various fields. And additionally, I will also say that when we find and match students into the projects, very often we try to find students not only with a technology or life science background, but finding some additional knowledge which the researcher lacking, and that could be from the social science. I think we have examples of students coming from the humanities as well.
Okay. And I mean, you seem to be very popular with our online audience. I mean, do these entrepreneurship programs also have impact on students' ability to find employment? I would guess I know the answer.
The easy answer is yes. The more difficult, how do you know that? But what I know, because I've actually been acting as a coach myself, not very recent, but before, and it's very common that when the students apply for their first job, they give the coach as a reference person. So I have given reference to potential employees, which did result in employment also, and I know that other coaches have been in the same situation. So a little bit vague answer to a difficult question, but there are some indication that it works. At least it's the students see the potential.
Many thanks. I think we're coming to the end of this session. I would really like to thank you very much and to thank all the people that online send their questions that you've got the opportunity to reply. Just maybe before we wrap up this session, I would like to invite you, I mean, maybe to give us one last message, each of you, that you would like to share today. Matthew, can we start with you?
Absolutely. So I'd really just like to encourage those who've never considered entering the space industry or considering space spin-offs as something that's for them. It absolutely can be for you. And I really encourage you to explore this opportunity. Please feel free to connect with myself, and I'll happily then connect you with your local technology broker, business incubation center, or colleagues also within the agency. And we'll really see how we can work best with you to get your product where it needs to be.
Thanks a lot, Matthew. Joe?
Knowledge valorization is a very complex process, and for complex processes, you should not work alone. It's not a one-man show. You have to build a team and find people with sort of experience and knowledge which sort of complements yours. So if you're a researcher and don't know anything about marketing, go find a student, and you will also find that the young students, they ask the questions which your colleagues do not ask, and you will get valuable input from people with different background.
Thank you very much. Francesca, please.
Yes, I think the key final message here, based on the forging experience, is that the future of industrial innovation cannot solely rely on technical efficiency and on technical consideration. In fact, if we want to achieve a model of innovation that is inclusive, sustainable, resilient, and human-centric, we need to incorporate in it social, environmental, and ethical factors, ethical considerations that will allow us to build common solutions to common challenges with as many perspectives and interests represented at European level. And also that innovation needs to rely on co-creative processes that involve the widest possible range of stakeholders, from industry, from academia, and we really need to be enhancing cross-sectoral dialogue both in industry and in academia, because everybody will benefit from it eventually.
Thanks a lot. Many thanks once again to the three of you. Thanks a lot to all of you online following us today. I think we will be able to, you will be able to join the next session of the EU Knowledge Valorization talk on the 14th of October, so don't miss this opportunity. It will focus on intellectual asset management, which of course is key to valorize a lot of the scientific results that you may have at hand. That was a real pleasure today to have you all, and also thanks a lot for all of you online following us and coming in with your question. And that was a pleasure for me to moderate that session. I wish you all a very pleasant day.